On a 2019-2024 Ram 1500 Classic with a 3.6L Pentastar gas engine, P0171 is a fuel system 1/1 lean fault. In plain terms, the PCM may be adding fuel because that side of the fuel control system looks too lean. The driver may see the MIL come on, and if the truck has stop/start, that feature may be disabled while the code is active. Broadly, this can come from possible air or vacuum leaks, fuel delivery issues, injector concerns, purge flow problems, engine mechanical issues, exhaust leaks, or MAP and upstream oxygen sensor signal and wiring problems. The PCM is trying to control around a stoichiometric air/fuel mixture of 14.7.1, so the diagnostic path is about proving whether the lean correction is real, sensor-related, wiring-related, or coming from the engine and fuel system. Before chasing the fault, make sure the monitor can actually run. The operating gate is engine running in closed-loop fuel control with battery voltage above 11.0 volts, barometric pressure greater than 75 kPa, ambient temperature above -7 degrees C, 20 degrees F, fuel level greater than 12%, and altitude below 2,598 m. 8,500 ft. The setting logic is based on fuel correction. When short-term plus long-term fuel correction is greater than a calibrated threshold, generally 133% where 100% is nominal, the fail timer increments. After approximately 30 seconds of fail time, the diagnostic fails. Start with the basic system checks first. Then use the scan tool to read and record the DTCs, and save the captured operating data. Start the engine, verify the fuel system is in closed-loop fuel control, and operate the vehicle under the same type of conditions that set the fault. Read codes again, and decide whether P0171 is active or pending. If it is not active or pending, treat it as an intermittent condition. The intermittent routine is a separate diagnostic path, so pause there and do not guess at the failure. If P0171 is active or pending, look at the rest of the recorded codes before going deeper. If other fuel or air handling faults are active or pending, handle those applicable diagnostics first. For this lean code, do not ignore related system faults that can change airflow, fuel control, or sensor reporting. If there are no other active or pending fuel or air handling faults, continue with the P0171 path. Next, check MAP sensor operation using the proper MAP operation test. If that test finds a problem, make the appropriate repair and verify the repair. If the MAP operation checks out, turn the ignition off and look for fueling or air handling issues. The air induction system needs to be free of leaks. Check the engine and vacuum hoses for vacuum leaks. Check the power brake booster for an internal vacuum leak by watching engine speed and vacuum while pinching the brake booster vacuum hose. If an injector is suspected of being plugged or restricted, remove the fuel rail with the injectors intact. Energize the fuel pump to maintain fuel pressure in the rail. Actuate the suspect injector or injectors with the scan tool. Inspect the spray pattern and compare it with the other injectors. Also check that the purge flow system flows freely with no leaks or restrictions, including the hose and connections between the purge solenoid and intake manifold. Engine compression must be within specifications. If an engine mechanical problem is present, make the appropriate repair and verify the repair. If not, continue. If the earlier checks do not find the cause, move in order through the system tests. Check the fuel delivery system using the proper fuel delivery test. If a problem is found, make the appropriate repair and verify the repair. If fuel delivery passes, check ethanol content in the gasoline using the proper gasoline ethanol level test. If the fuel is the issue, correct it and verify the repair. If that passes, check the exhaust system for leaks using the proper exhaust leak test. If an exhaust leak problem is found, repair it and verify the repair. If no problem is found, move on to the upstream oxygen sensor circuit checks. For the upstream oxygen sensor wiring check, disconnect the upstream O2 sensor harness connector and disconnect the PCM-C2 harness connector. Use the GPEC Diagnostic 10436 adapter. Do not probe the PCM harness connectors. Probing them can damage the PCM terminals and create a poor terminal-to-pin connection. Check the upstream O2 sensor circuits between the sensor connector and PCM-C2 for a short to ground and for an open or high resistance. If a wiring problem is found, repair it and verify the repair. If the wiring checks good, perform the oxygen sensor operation test. If that finds a problem, repair as necessary and verify the repair. If the oxygen sensor operation test does not find a problem, continue to connector inspection. At the final stage, disconnect all PCM harness connectors, any related inline connectors if equipped, and the related component connectors. Inspect the harness connectors, component connectors, and male and female terminals for correct installation, damaged locks, corrosion, water intrusion, seal damage if equipped, bent terminals, overheated or discolored terminals from a poor connection, and terminals pushed back into the cavity. Check for spread terminals and verify proper terminal tension. Repair anything found. Then reconnect the PCM connectors, inline connectors if equipped, and related component connectors, making sure they are fully seated and locked. Erase the DTCs, test drive or operate the vehicle under the monitor and set conditions, then read codes again. If P0171 returns after all of that, replace and program the PCM using the proper programming process, then verify the repair. If the code does not return, the problem was poor connection related, so complete the connection repair and verify the repair. The key with P0171 is to prove the lean condition in order. Confirm it is active, rule out related fuel and air handling faults, check MAP input, look hard for real air, fuel, purge, mechanical, and exhaust issues, then finish with O2 wiring, O2 operation, connector integrity, and only then the PCM decision. For more diagnostic training, visit stepdiagnostics.com.